In this video, this will be a, I suppose, a brief walkthrough on how to solve problems, particularly quadratic equations, by completing the square. So, uh, I am making this video to commemorate, well, not exactly commemorate, because I didn't know how to complete this, to use completing the square before this video. I think I really know how to. So, I want to make a video out of it, basically. Okay. So let's go with number two. Um, I wasn't still sure if I'm able to apply the instructions, so I did number one on my own, off cam. We'll be solving, I don't know, definitely not all problems. Otherwise, it's gonna take a lot of time. Um, okay, let's start with number two. Um, so we transpose the constant to the right side, uh, just like that, and then what's next? The coefficient of the term with the highest degree of, well, the one with the highest exponent, basically, we divide everything by its coefficient. So as you can see here, v raised to 2 is, well, the coefficient is 1, so we divide it by 1, which doesn't change anything. It's still the same, basically. But given that the same term, let's say the coefficient is 2, then we divide everything by 2. So we'll stick to this. What's next? So we look at the second term. We see that it's 6v. We divide the coefficient of that term by 2. So we have 3. And then we raise it by 2. Then we get 9. Where do we place 9? At the left side of the equation, here. We place a plus 9 and a minus 9. It's always standard to have a plus and a minus written in this way. And then don't forget 59 at the right side. The recent notability update is a little weird. There's definitely more areas to improve on. If you're used to the previous layout of how do you use notability, then right now it's going to be a challenge. Anyways, these first three terms we need to factor them. This is crazy. I'm not liking this new update. It's getting annoying. Okay, so we factor these three terms like this, and then place 59 at the other side. We place a square root on both sides, and then don't forget a plus minus at the right side. Okay, and then we transpose 3 to the right side. We get this. I suppose the answer could be written as positive square root of 59 minus 3, negative square root of 59 minus 3. Let me just confirm with the answer key. Actually, we can still simplify the square root of 59. Okay, I made a mistake, but it's not about the process on how to apply completing the square, it's a common sense problem. Well, as you can see here, basically what I did there was, well, factor them. Where did the negative 9 go? It didn't go anywhere. It was supposed to be combined with 59. So 9 plus 59, that's 68. But before um, proceeding here, let's simplify the square root of 68 first. How do we simplify that manually? We have definitely not 3. 4. 47 times 2. Yeah. Well, no, not yet. Maybe not 47 times 2. 17 times 4. And the 4 becomes 2 raised to 2. And that makes this square root of 68 equal to 2 square root of 17. So instead of this, we place 2 square root of 17. Okay. Correct me if I'm wrong, if using this kind of format for the solution is wrong. Actually, I'm not sure, but definitely the values are correct if we're trying to look for the answer to the corresponding question. The potential mistake may be in the aspect of formatting. Number 3. Okay, let's do the same thing. Transpose constant to the right side. Divide all sides by the coefficient of the term with the highest degree, which is just 1, so we don't change anything. The second term has 14a. 14 divided by 2. The half of its coefficient is 7. And then we raise it by 2. That's going to equal to 49. So plus 49 minus 49 is equal to 51. Factor plus 7 raised to 2. 49 plus 51 is 100. Square root both sides. Plus minus 100. This is very smooth. Plus minus 100 minus 7. A is equal to 93. A is also equal to negative 107. I think that's the case. Is it? By the way, this is correct. Okay, something's wrong. Yeah. Careless mistake. This is not about this isn't a skill issue regarding how you apply completing the square methods. Well, if you place a square root on both sides, the 100 has to be 10. Okay. A lot of injuries right there. Okay, 3 and negative 17. According to Kuta Software, the format could be written simply as this. Okay, number 4. x raised to 2 minus 12x is equal to negative 11. Divide both sides by the coefficient of the term with the highest degree, which is just 1, so nothing changes. Let's look at the second term's coefficient. We divided by 2, so that's going to be negative 6. By the way, we consider the negative sign as part of the second term. Why? Because the format of this quadratic equation is written as ax plus bx plus c is equal to 0. So as you can see here, it basically says that the negative sign is part of the bx. Essentially, in the formula itself, there's no negative sign. So anything that's negative is specific to the given example that corresponds for the second term of that equation, which in this case is negative 12x. So, okay, what's next? So we have negative 6, right? And we have to square it. That's going to equal to 36. Okay, so x raised to 2 minus 12x. And then we place plus 36 and then minus 36 is equal to negative 11. Negative 6, negative 6. Okay, so that's x minus 6 raised to 2. 36 minus 11, that's going to be 25. Okay, square root both sides. We're going to get a plus minus 5. And then 6 plus minus 5. X is going to equal to 11. The other x will be equal to will equal to 1. So we have 11, 1, which is said to be correct according to the answer key. Okay, I think I am getting the hang of it. Let's keep going. X plus 6x is equal to negative 8. Well, x raised to 2, not just x. Divide both sides by the coefficient of the highest of the term with the highest degree. Nothing changes because it's equal to 1. Then the coefficient of the second term, which is 6, well, you divide it by 2, that's going to be 3. And then you raise it by 2, that's going to equal to 9. X raised to 2 plus 6x plus 9 minus 9 is equal to negative 8. So if you're wondering where this came from, it came from this. Where did 9 come from? It came from this. Where did the raised to 2 come from? Well, it's part of the protocol. You raise to 2, whatever is the value of the half of the coefficient of the second term. It's gonna take a while to absorb what I just said, but yeah, it wasn't really easy for me either to understand it, but now I understand it. Okay, x minus, plus 3. 9 minus 8, that's going to be 1. X plus 3 is equal to plus minus 1. X is equal to 3 plus minus 1. Negative 3. Careful right there. Negative 3 plus 1, that's going to be negative 2. X is equal to negative 4. Negative 2, negative 4. According to the answer key, that is correct. Okay, next. So we have 2, right? Negative 2, actually. It's going to be 4 plus 4 minus 4 is equal to 3. And then Something's wrong. Something doesn't look right. This cannot be. Hmm. Actually, I have no idea how to solve this. This is a different challenge. It's not like the questions that we have previously encountered. This is different, definitely. The heck? Give me a minute. Let me try photomath. Plus, I'm so tempted to factor the problem. So, you can already see the answers already, even if you haven't factored it yet, at least from my perspective. But what we have to do is solve it by completing the square, not by factoring. So that's a real challenge. If we had the liberty to use factoring, then we could have I could have already solved it a few minutes ago. So I'm guessing there's a formula for this one. This is a special kind of completing the square. Okay, so this is the formula, they say, according to photomath. Um, okay. Let's try that one. So we place a plus 1 instead, right? And again, the constant is supposed to be at the right side always. So essentially, we just place a plus 1 here and a plus 1 there. And then we can factor. Okay, so from there on, we can say that the n values are 3 and -1. Fourteen divided by 2 is 7. And raised to 2, that's going to be 49. $64. So 8 minus 7 is going to be 1. And then -15. 1, -15. Is this the correct answer? Yep, it's correct. Let's try this one. Yeah. -6. -4 raised to 2 is equal to 16. Okay, it's not working again. How about +2 this time? No, +4. That should work. And then -2 at the other side. I'm sensing an imaginary number here. Because if you proceed in placing a completing this, well, if you proceed in placing a square root on both sides, there ain't no such thing as a value that's encased in a square root sign unless you consider it or you call it an imaginary number. In that case, let's transpose negative 2 to the other side. So that's going to be like this. According to the answer key, the answer is 2. By the way, where is the plus minus? 2 plus I square root of 2 to minus I square root of 2. So this is the answer. Take note. How this becomes this and this. How about this one? Let's solve this fast. 2 raised to 2 is equal to 4. Okay, that can't be possible either. I guess at this point we're just supposed to think of possible numbers. So let's experiment. How about 4? No. How about 2? It wouldn't work either. How about 1? Should work. Okay, and then negative 19. B plus 1 is equal to the square root of negative 19. I 19. Okay. We're going to deal with something that's imaginary again here. There you go. And then I square root of 19 minus 1. So, answers are negative 1 plus I square root of 19 and then negative 1 minus I square root of 19. Okay. Whew. Let's try this. Negative 6 raised to 2 is equal to 36. Okay, so our very first trick isn't working at this point in the harder problems. What do we do? Let's try 9. At this point, I'm just guessing numbers. Of course, you just don't guess. You see if the number is going to be relevant. You see if it can be instrumental in having a perfect match for factoring. So in this case, I can see that if you factor, then yeah, it's just a match. You just have to solve it mentally. 91, 81, negative 82. V minus 3 is equal to Square root of negative 82. Plus minus, don't forget. V is equal to 3 plus minus I square root of 82. Okay, good. Let's try 15. Okay, so this time, the term with the highest coefficient has a coefficient. But sorry, the term with the highest degree has a coefficient. Do you think it's wise to divide both sides by 5 so the numbers become smaller? Well, the coefficients become more simplified. I think it's okay, technically, in the rule on fractions. Okay. Now this is a lot better. What's next? Divide both sides by the coefficient. Well, we don't have any more. Technically, it's just 1, so nothing changes. That's what I mean. Four raised to 2 is equal to 16. I think this is gonna work. It is not. It's not going to be 4K in the middle. Okay, let's try 8. No. How about 4? Yep, 4 is a good match. Well, I think it is the only match that we ought to look for. Again, where did 4 come from? It didn't come from out of nowhere. You just think, what's the third term that can make these 3 terms factor completely? So that's what you have to ask yourself. K plus 2 is equal to plus minus 4. Okay, plus 4 minus 2, that's going to be 2, negative 6. That is correct. This is correct. How about number 18? N, right? Oh, wait. We can't simplify. If only... Hang on. 9, 18, 27, 26, 5, 6, 8. Yeah, if only this is... If only the constant was 72, then we might be able to simplify, but that's not the case. So, first protocol, I think this is the first time we'd be able to use the very first step. It's the first time that we're dealing with an example whose whose term with the leading degree has a coefficient that's greater than 1. Well, basically we're gonna solve it for the first time, something like it. So first things first, instead of dividing both sides by 1, we divide everything by 9, according to what is the coefficient of the term that has the leading degree. I keep saying coefficient instead of degree. Okay, so n raised to 2 plus 2n, and then negative 79 over 9. We just keep it that way. 2 from the second term that becomes raised to 2, we get 4 plus 4 minus 4, negative 79 over 9. Factor n plus 2, right? Nope, it would not. Okay, our very first trick did not work, evidently. Let's try plus 2 on both sides instead. No, it didn't work. Let's try 1. Definitely 1 would work this time. It should. Yes, it did. 9 over 9. Negative 70 over 9. Square root both sides, n plus 1 is equal to plus minus square root of negative 70 over 9. I'm smelling something that's going to be imaginary here. So we have this imaginary and then 70 over 9. I hope I'm not wrong. Okay, before that though, we can actually still simplify the denominator part. Before placing an imaginary sign, we have negative 70 at the top. Below we have over 3. We'll just place 70 there and then I over there. So another step, we write something like this. Negative 3 plus I square root of 70 over 3. Negative 3 minus I square root of 70 over 3. Okay, so far so good. Actually, I like this problem. Let me screenshot it. Okay, next. Last 2 questions, I suppose. Last 3 questions. I want to try 21. It's almost 11 p.m. Still have a lot to do. After this, I'll be solving more questions. This is just a basic practice. Yeah, anyways. 4n raised to 2 plus 4n is equal to negative 36. Simplify. And then divide both sides by 1. Nothing changes. Negative. Okay. 1 divided by 1 is 1 raised to 2 is still equal to 1. So one minus 9 is negative 8. And plus 1 is equal to okay, so I square root of 8 minus 1. Don't forget the plus minus. Am I on the right tracks? Answer key says I'm not. Where did I go wrong? Yeah, I see where I got it wrong. We weren't supposed to proceed. Uh, Actually, the plus 1 minus 1 didn't work. It wasn't gonna work, so what do we do instead? Plus 1. How about just plus 1? Let's see what happens. Well, it's not possible either. Let's try 1/2. More likely, because 1/2 plus 1/2 is equal to 1. So it suits that at least. But this one is going to be 1 raised to 4. This is 1 raised to 2. Let's see if we could factor this. I'm just very curious. We actually can. Wait, we can't. Yeah, we can't. This is where completing the square becomes very important. I think another method is by quadratic equation. Sorry, quadratic formula. Actually, this is the hardest question so far. What the heck? Let me see if I could solve this by quadratic. Never mind. Okay, so I think we're close. I'm comparing my solution to Photomat's. Instead of 1/2, they use 1/4. I did I did think about placing 1/4 earlier, but I didn't think it was gonna yield the right answer. Let's try it out. Actually, yeah. I can't believe it. You're very used with constants, but not fractions. So you never knew 1/4 could be written as 1/2 in the sense that, well, this entire thing is equal to this, basically. Thirty-six, 35 over 4. I think we can proceed. I'm very close. I was very close. Oh wait, no. Plus minus I square root of 35 over 2, right? And then minus 1 half. This can be written as I square root of 35 minus 1. Separate into two parts. We have I square root of 35 minus 1 over 2 negative I square root of 35 minus 1 over 2. Yep. Now we got the correct answers. You know what? Let's answer all 4 questions. The last 4 questions. I believe these are the most challenging ones. Okay, you can't divide anything. So divide, well, you can simplify the coefficients. There's no common factor. So divide both sides by 7. Okay, so if ever our first trick won't work here, then I'm sorry, I wouldn't be able to solve this anymore. Negative 16 over 7 divided by 2, so that's times 1 half. So negative 16 over 14. And then put a raise to 2. 256, is it? Over 196. Mm. 64 over 49. Eight over 7. Okay, I am pretty sure this cannot be completely factored. Wow. This question is next level. We're not answering this. GG's. 23. Negative 68. Okay. I bet our first trick wouldn't work here either. Let's improvise. How about 1 over 5? No. 1 over 25. It should work. Wait, let's try that. Actually, 1 5 plus 1 5, 1 over 5 plus 1 over 5, 2 over 5. Huh, it worked. Okay. It did work. Let's see what's gonna happen next. And then 25, right? 5 times negative 34. 170. Negative 169. Fair enough. Square root both sides. (13 raised to 2). But first things first. This is the numerator is gonna be imaginary. That's the thing. So, but below we can still liberate it from being subject under the square root symbol. Has anyone noticed my stylus started becoming thicker? Wow. Anyways. What's next? Plus minus I square root of 169 over 5. Transpose 1 over 5 to the right side. Minus 1. What number is this? 23, right? Okay. Technically, this is still 13. I13. Can be written as 13I. So we have positive 13I minus 1 over 5 and negative 13I minus 1 over 5. Let's see if I'm correct. Yep. 24. Actually, let's solve 22. I think I know what to do. No need this, no need to do this. Negative 16 over 7. Four over 49. Let's see if that works. Wait, 8 over 49. But no. It's not gonna be a perfect. Negative 4. How about 16? No. 64. More like it. Uh, so if we spread this out, so negative 8 over 7k plus negative 8 over 7k, that's gonna be this. So that's a good thing. It matches. How about this? So 8 times 8 is 64. 7 times 7 is 49. Okay, we're good there. I think we just found what we're supposed to look for. What we wanted to look for. Let's bring this somewhere. Negative 700 plus 64 is negative 636. And then square root. Wow. This is actually crazy. So k minus 8 over 7 is going to be plus minus at the right side. Plus minus negative, plus minus square root of negative 636 over 7. 8 over 7 plus minus. Let's simplify negative 636, which is under the square root. So that's going to be 2 square root 159. And because we have a negative value that's inside sorry, I'll be right back. Sorry about that. Let's continue. Okay, again, we place an I because, again, a negative value that's inside uh, a square root symbol is imaginary. So yeah, write something like this. 8 plus minus 2i square root 159 is equal to k. We have 8 plus 2i square root of 159 over 7 and 8 minus 2i square root of 159 over 7. Let's confirm if the answers are correct. Alright. Let's answer 24 here. So there's more space. Doesn't look too crowded. Divide both sides by 3. So what can we multiply Uh, say 964 minus 8 over 3. Maybe we've already found the right value for the denominator. Maybe make the numerator a little smaller, less than 64. Let's try 16. 4. Perfect match, I think. Perfect match. Perfect match. I'm so happy. Okay, so the left side will be written as this. The right side, simplify 9 negative 20 over 9. Square root both sides. Plus minus. I think this is it. I wonder why there are no imaginary numbers in the answer key of number 24. What's supposed to be the answer according to Kuta Software? I think I found a mistake. So, this is not supposed to be negative 20. So it's supposed to be 4 over 9. How did I still make a mistake in that? But this, by the way, I believe it's correct. I thought it was very cool. Then I realized it's not the correct answer. Okay. So, plus minus 2 over 3. Two and then 2 over 3. These are the answers. Alright, I think we're done. Are we? Yes way. We are finished. Not all questions were answered, but at least we answered at least more than half of them. Thanks for watching. I'll see you soon. Cheers.